This is Mr. Ashton going through the mathematics paper from the summer of 2018. Look at the non-calculated paper. As this is the higher tier, a lot of the questions that have been covered, the first 9 questions in higher, are also in intermediate. So rather than going through them here in this video, they are in the intermediate version, which I'll try and send a link to as well within this video. Okay, so the first question that was a higher only question said the following. Enlarge the triangle below by a scale factor of -2. Now, the reason why this is question 10 and not like question 1 or 2 is because it goes into an A grade question. And the whole reason why is because of this minus idea. It says use the origin, so I'd expect us to know origin just means 0, 0. And then to do a scale factor of -2. Well, let's first of all mark out where the origin is, so there, where the axes meet. Now, how do I get from this vertex to the origin? I go up 2 and across 1. Well, because it's -2, it's now going to get twice as big, but it's going to go in the opposite direction. So instead of going up 4, it's going to go down 4. Instead of going to the right 1, it's going to go to the left 2. Okay, so that's how I'm going to plot that vertex. So go down 4 and across 2. Okay, so just map the vertices for now. Next vertex, I go across 3, up 2. So I now need to go across -6 and then down -4. And then this final vertex here, which we can see is 3, 3, now needs to be twice as big as that in the opposite direction. So it's going to be -6, -6. There. Okay, then get your ruler on it and join up the vertices. Now, one way that you can use to check it, does make your work look a bit messy, is if you get the corners and you join up the appropriate corners of what it was in the enlargement. It should all go through the origin, which you can see mine does do that. Okay? Don't need to do that, it's just a way of checking it. Okay, so question 9, that's the one that I've already done the intermediate paper, so I'm not ignoring it, it's just I've already done it. Okay? Question 11. Given that y is directly proportional. Okay, now if something is directly proportional, we can say that y equals k, whatever this bit is, k root x. I now need to sub in y equals 30 and x equals 36 into this statement here. So y equals 30, so that's going to change to 30, equals k times by the square root of 36. The square root of 36 is 6, so I can say 6k is equal to 30, and then 5 is equal to k there. What I need to do now is always come back to this original statement that I've made and sub in what I've just worked out as the value of k. I've just worked out that k is 5. So I now come back to that. I'm going to say, so y equals 5 square root x. Okay, so now I'm going to go and work these out here. First of all, it says work out y when x is 49. So I know that y is equal to 5 times by the square root of 49. The square root of 49 is 7. So y is equal to 5 times 7. So y is equal to 35. And then the other one here, we're actually told what y is. So you can say 40 is equal to 5 square root x. I'm going to divide both sides by 5 to get 8 equals the square root of x. And then I'm going to square both sides to get x is equal to 64. So 64 would go there. Okay then, in terms of the next question for congruency, you need to know 3 rules, okay? So side, angle, side, or actually 4 rules. Angle, side, angle, side, 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 or right-hand side, okay? Now, I'm going to go through these very briefly. I'm only going through papers. I'm not teaching you how to do it. I'm just going to tell you how these work in these type of questions. Now, I am looking for this one here. Really, I should have put an I in front of that as well, okay? An included angle, because that bit's really important, and that you'll only get the mark if you include that bit there as well, okay? Now, what I'm talking about is when I've got my sides of 3.9 and 4.4, where those two meet, I've got to have that angle there. That's 65, okay? So here, when I've got 3.9 and 4.4, can you see I don't know what the angle is there? I've only got one angle given. So A and C are not congruent to each other, these two here, because I don't know what that angle is there in the middle. Similarly here, I've got 3.9 and 4.4. I don't know what the angle is, so I can't say those two are congruent. And then here, 4.4, 3.9. The angle included in between them, don't know it. I know this one's 55, but it's got to be in between those two sides. And then here, 3.9 and 4.4. It's 65. Those two are. Okay, so A and G are. Okay, so triangle A is congruent to triangle G, and the condition is side, and you must say this word here, included angle, side. That is the condition for it, okay? Side, included angle, side. The next one I'm looking for, these two here, you can see that all the angles are the same, but that's the condition for similar triangles. And we know similar triangles aren't necessarily congruent from other work that we've done previously, i.e. that you work out scale factor and work out what the enlargement is, okay? So they're just similar. We don't know they're congruent. To be congruent, you have to be exactly the same size, have all the same angles, that I could literally pick this one up and plug it on exactly the same. Now, because those two we can't tell them they're what we call similar, I'm trying to look for another one. Now, I've already used one of those. That one doesn't come up where I've got just two angles, so I'm looking at side, side, side. So this one here, got a 5.1, 3.9 and a 4.4. Have we got exactly the same sides anywhere else? 5.1, 3.9, 4.4. It doesn't matter which order they come in. As long as you have all those three sides, those two will be congruent, okay? So it's D and E. So triangle D is congruent to triangle E, and the congruency condition would be side, side, side. Okay, question 13. A ball is thrown upwards from a height of 1 meter above the ground. After t seconds, its height above the ground is h meters, where h is given by h equals 1 plus 8t minus 5t squared. Show that the time taken to reach a height of 4 meters satisfies this equation. Now, we've just been told here, h is given by this formula here, and that h is this many meters, and it's in h meters. So for it to be 4 meters above the ground, we can put 4 equals 1 plus 8t minus 5t squared. You'll notice with their 5t squared, it's not negative, it's positive. So they brought everything over to this side. So keeping the equals there, I want to have nothing left on this side. So that minus 5t squared will come over here to be positive. That plus 8t will come over to be a negative 8t. And that plus 1 will come over to minus 1. 4 minus 1 is plus 3, which is hopefully what they've got. So I've just proved it satisfies that equation. The next thing they want me to do is to solve that equation, and this is without a calculator. Now, the way that I do these might be slightly differently to how you do them. I'll show you how I do them. I multiply the first and the last term together. So 5 times by plus 3 gives me... I then look at what this middle term here is. It's minus 8. I've got to think of a pair of numbers that times together to give me a plus 15 and add together to give me a minus 8. Now, if they times together to give me a positive, then either my two signs are positive or they're both negative. The fact that they add together to give a negative number means they must both be negative numbers. You now try and write down a pair of numbers that times together to give me plus 15, so minus 15 times minus 1, which would give me that. However, minus 15 minus 1 gives me minus 16, so that's not my pair. So I'm now going to think of another pair. What other pair of numbers times together to give me 15? 5 and 3. Minus 5 times minus 3 gives me plus 15. Minus 5 take away 3 gives me minus 8. That's my pair. Now the way that I do these now is I look at this thing here, which says 5t squared. I drop just the squared from it. I say 5t at the front of each bracket. Okay. In one of my brackets is going minus 5, and in the other bracket is going minus 3. Okay, so minus 5 in one bracket, doesn't matter which one, minus 3 in the other. If you use this method, what you must do is you must cancel down any brackets that can be cancelled down. So 5 and minus 5, I could divide both by 5 to get t minus 1, and this one here becomes still 5t minus 3. There's not a number that goes into both 5 and 3. Then I solve it by getting t equals 1 or t equals 3/5. Okay? Now, the next question says, interpret your answer to part B in the context of this question. Now, I've got two answers there for what my answer could be, where it's 4 meters above the ground. Now, in terms of that, I've got two answers, so 3/5 of a second and 1 second. Then I would assume the particle's doing something like that. That's at 4 meters high. And then this took me 3/5 of a second. And then when it's going down, it took me 1 second. So it is at 4 meters high twice, once going up, once coming down. Okay? Question 14. Now, this is just knowing your rules of indices for this. Because I've got a fractional indice, you look at the denominator. Because it is over 2, that means I square root that number in a bracket, put it to the power of the numerator. What is the square root of 9? 3. And then I need to cube that answer. 3 cubed is 27, so I'm looking for the answer 27. This one here, quarter, means that it is to the 4th root of 10,000 to the power of 1, and the minus bit, this bit here, ready? Oh, not minus 1 over, just 1 over. That's what the minus means. It means 1 over, okay? So that is going to be 1 over what number times by itself? So I'm going to say x times by x times by x times by x equals 10,000. So what number times by itself repeatedly is 10,000? Well, the only number that can do that surely is going to be 10. So I'd assume it's 1 over 10, which is my answer here. Next question, number 15. The way I do these is I say, let's let x equal that decimal. Okay, now the most important thing to do with this is the spacing. You'll notice that I'm spacing it out. 4, 5, 4, 5, 4, 5. That's what those two dots mean. Okay? They mean that that 4 and the 5 repeats, okay, or recur. Now, however many dots are there, the fact that there's 2, that tells me how many times I'm going to times my x answer by with a 1 in front of it. So, i.e., 2 dots equals 100. 1 dot would have been 10, 3 dots would have been 1,000, 4 dots would have been 10,000, and so on. If I'm timesing it by 100, all of these numbers will move in place value 2 places to times by 100. So I'm looking for the 2, 4 to come here into the tens and units column, followed by a 5, followed by a 4, 5, a 4, 5, a 4, 5. Timesing by that 100 has kept all those 4 5s in the same order. So now, when I subtract those two there, so again, line at the equals, line at the decimal, 5s cancel, 4s cancel, 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 stop. 5 take away 2 is 3. 4 take away nothing is 4. 2 take away nothing is 2. Careful with this. 100x take away x is not 100, 99x. Now I need to divide both sides by 99, so 24.3 divided by 9. Now the problem is I have not written that as a fraction. That's not a fraction as it stands. The reason why that's currently not a fraction is because it has got a decimal in it. Fractions and decimals should not be mixed. So I'm going to times that by 10, but whatever I do to the top, I must do to the bottom. So it would be 243 over 990. There's no need to simplify that down to get any extra marks. Next question regarding surds. Simplify and expand. So that first term here will multiply both of these terms here. Second term here will multiply both of these terms here. So I always draw these arrows to help. 8 times by 5 gives me 40. 8 times by plus root 7 will give me 8 root 7. Minus 3 root 7 times by 5 will give me minus 15 root 7. And then minus 3 times plus, so it's going to be a minus. 3 times root 7 would be 3 root 49. Okay? Now, in terms of that, I can answer this bit here. That's effectively 3 times 7. That's going to stay the same. And these two guys here, I can merge. It's like having plus 8x take away 15x. That answer would be minus 7 root 7. Okay? 21, 40 take away 21 will give me 19. Should be getting some equals here as well. 19 take away 7 root 7. Okay, so the next question. Draw the graph of the curve y equals 2 to the power of x from the values of minus 2 to plus 2. So the first thing I'm going to do is what we'd always do when we're drawing a graph, is start by drawing an xy table. So x, y equals 2 to the power of x, and they want me to do it between the values of minus 2 all the way up to 2. Okay, so we go in integer form there, so minus 2, minus 1, 0, 1, and 2. 2 to the power of minus 2. Well, we know the power of a minus means 1 over 2 squared. 2 squared is 4, so that is 1 over 4, okay? Or you could say 0.25. 2 to the power of minus 1 would be 1 over 2 to the power of 1. 2 to the power of 1 is 2, so that's just a half, 0.5. Anything to the power of 0, 2 to the power of 0 will be 1. 2 to the power of 1 is 2. 2 squared is 4, okay? Now I need to plot those values. So minus 2 1/4, so let's work out the scale here. So I'm going to assume 1, 2, 3, 4, as that's what my highest value was. There's no point in going higher than that. It's as if it was made for it to be that. And then minus 1, minus 2. They didn't ask for minus 3, but I will write it in. And then 1, 2, and 3. Okay, now I'm going to plot those values. So the first thing I'm going to plot is 0, there's 1, there's a half, so it's a half of a half, so it'll be 2.5 little squares up there. This will be bang on a half there. Okay then, so we have all of those there. As they did tell us, this is going to be a curve, so we do this freehand, not with a ruler, and I have it coming up. So I'm just turning the graph paper to make it more easy for me. The best job here, actually. Okay, so doing something like that, okay? It then says, use your graph to find the value of 2 to the power of 1.4. So 1.4 would be down here, because that's what the values of x's were. That was 2 to the power of x, wasn't it? So we're looking on the x-axis for 1.4. Hit the graph and come off, and I work that out as 2.6. Y equals 2.6, but he finds just say 2.6. And then this one here says 2 to the power of x, sorry, just so you can see, 2 to the power of x equals 1.4. Now that's an easier question in some respects. When it just says it's equal to 1.4, I draw a line on the y-axis at 1.4. Oh, not the straightest line I've ever drawn. Try that again. I'll look for where it hits the curve, which is dead on there. Okay, and then I can see that for me is in between 0.1 and 0 and 1, which would be 0.5. Okay, so the answer I've written in there is 0.5. Question 17 says, at a children's party, the children play a number of games. The winner of each game chooses a ticket for a prize at random from a box. The ticket is not returned to the box. Okay, now that's really important. They usually bold that for you. Okay, the ticket was not returned to the box. We're on question 17. We're doing probabilities. It would make sense. This is what we call conditional probability, or probability without replacements, I tend to call it. At the start of the party, there are 12 prizes available: 1 book, 3 key rings, and 8 pencils. Find the probability that the winners of the first 2 games chose the same type of prize. Okay, well, there's only 2 types of prizes that we can win twice. If you win the book, it's gone. You're not going to get it again. So I'm only after 2 in particular. So I'm not going to try and do trees for this. What is the chances that I win 2 key rings? So a key ring, and then a keyring again. The chance of getting a keyring, there are 3 available out of 12 of the prizes, so it would be 3 out of 12 times by, one of those keyrings is now gone, so there's only 2 left out of a total of 11. Okay, I then work that out. 3 times by 2 is 6. 12 times 11 is 132. And then the chance to get me 2 pencils in a row, so probability of getting a pencil and a pencil again, would be 8 out of 12 times by 7 out of 11, which will give me 56 out of 132. Now, because there are 2 different ways that I can get 2 of the same prize, what I do is I add together those 2 probabilities. So I do 6 out of 132 plus 56 out of 132 to get a total of 62 out of 132. No need to simplify that down. We're then said, after the winners of the first 3 games, so it's changed now, have chosen their probabilities, or chosen their prizes, find the probability that the ticket of the book is still in the box. So the chances of me getting a book is 1 out of 12. So the chances of not getting the book, that's what I'm interested in here, that the book is still in the box means that I've not got it. The chance of the first person in not getting the book would be 11 out of 12. Next, I go in. One of the probabilities of not selecting of 1 less in the box in total. And I then do the same again for the third one, because it's 3 games, and I get 9 out of 10. Now that might be quite a hard one to actually go and work out without a calculator. There's some really easy ways that you can make this a lot easier on yourself. What you could do is do 11 times 10, which is 110, times that by 9 is 990, and then do 12 times 11, which is 132, and times that by 10 and get 1,000. Okay, that's not too bad, actually. So 990 over 1320. Now, you're not asked to put that in simplest form, so that answer will be absolutely fine. I thought it was going to be a bit harder than that when I did my model answers. And what I did when I wrote out this calculation here was, because they were timesing, is I can actually simplify top and bottoms across the whole calculation. So I could say divide top and bottom by 11, so those 2 cancel down. Divide top and bottom by 10, so those 2 cancel down. So I get 1 times 1 times 9, and then 12 times 1 times 1, which is 12. So 9 over 12, or I could say that's 3/4. Any of those answers will get you the full marks. Okay? Okay, on to easily the hardest question on the paper. You've got to be really good at the question. When I looked at it, I had to really think myself. Okay? It says, given that cos 21 is equal to 0.336. So what I need to do is just try and work out what this looks like at the graph. Because they're giving me that. They're expecting me to use it. Okay? So I look for 21 on the graph. Here it is, about here. Just roughly there. Okay? 21 up. Hit the graph. You can see it's very, very, very close to 1. In fact, it is 0.9336. Okay, 0.9336. Now, they want us to go and work out what is the minus version of that. Okay, they said, can you go and work out what cos x equals minus 0.9336? Those 2 are the same things. So if I look to see what that is, it's going to be just above 1, isn't it? It's going to be just above it there. Okay, now can you see that I'm going to get 2 solutions, one here and one here? Okay, now what they want us to be able to do is to work out the symmetry of what's going on in this graph. Now it's very, very similar to what's going on here. I've worked out here, to get this value, that there is a gap between 0 and 21 of 21 degrees. That's how much this gap is worth. Well, that gap there will be the mirror image here. Okay, so where I've got this answer here, this gap is equal to 21 degrees. It's also true on the other side. This gap here is also equal to 21 degrees. Okay, so if that is 180, to go and work out the values of that, I do 180 degrees take away 21 degrees, and 180 plus 21 degrees. So that was probably easier to work out, 201 degrees, and this one would be 159 degrees. Okay? It then says for part B, use the following axes to sketch the graph of 2 cos x. Now, I'm going to grab some tracing paper that I've already used previously, but there should be enough room on that. Just going to trace this curve here. It's roughly there. Okay? That's from the other bit of the question. We know that the graph of cos does this. Now, the fact that it is getting 2 cos means that where it's got my points, here and here and here and here, my key points here. So at 0 it's 1, 90 it's 0, at 180 it's -1, 270 it's 0, and at 360 it's 1. And now you're going to get doubled. Okay, so double of 1 is going to be 2. So it's now going to go through that point there. Now, where's my pencil? I should be using a pencil here. At 90, it's 0, so that's going to get doubled. Well, anything that's 0 that's doubled or tripled or whatever is going to stay the same. At 180, it's going to get doubled, but it's going to go down to -2. So we have to go and identify that number there on the y-axis. 270, it's going to be 0 still. And at 360, it will be double of 1, which will be 2. Okay? Now, it's going to look just like that curve, except it's going to get stretched vertically. Okay, so it's going to look something like this. Okay, now the other question is probably easier in some respects to draw if I've just traced it like I did. It says, draw the graph of cos x equals y equals cos x -1. Now, this is the graph of cos x. If it's been taken away 1, the whole graph moves down from one place. So this goes through at 1. So if I write that at 1 there, literally, it's just going to move down one place. So now, rather than going through 1, it's going to go through 0. And that -1 value it would have gone through will now be -2. Okay? So all of these points here remain the same. So I'm just pressing them with my pen to get them onto my graph. So hopefully now, don't know how well you saw that actually. I didn't have my eyes on the screen. What I just did, so I said, well, the graph of cos we know does that. If I'm -1, it's going to move down just one place, so it'll all be below the x-axis. Okay, so now that 1 would be 0, 90 would be going through at -1. Make sure you mark that on the y-axis. 180 would now go down one value to -2, -1, and 0. Okay. So it looks something like that. Okay, and that was the last question on the paper. If that was useful, please hit the subscribe button if you want to have access to more past papers as and when I put them up. Thank you very much for watching.